Dear students, today we will discuss about the Scilab programming. Scilab is a software for scientific computing. It is open source software, so we can download it freely from the Google. To download it, we write Scilab in the Google page and we will look like this Scilab download, and we will get the various version of the Scilab. We are using the 6.0.2 version, and in the 6.0.2 version, if we go to download, then it will ask whether the machine, our laptop or desktop, is 64-bit or 32-bit. Knowing the information of the desktop, we have to download that particular version, and the particular version will be downloaded, and the shortcut will be created in the desktop. There is option, and the shortcut will look like this, and when you open, double clicking on this, then there will be few seconds to open, and it will look like this. So this is the console where we can write anything, any command we can write here, and command history are there is a command history, and here the files, name of the documents where we can get the various values. Now in the console we try some simple things, that 2 plus 3 is simple mathematics, it comes out 5, that it is computing, and it is working as a calculator. CLC, that is clear the screen. Or you want to clear this console? Yes. Today we will discuss few basic things about the Scilab. In evaluating the matrix inverse or matrix diagonalization or matrix eigenvalue formation, which is included in the same portion of the syllabus, we can easily do this in using Scilab. So a matrix can be written like this: A equals to third bracket 2 3 4, and this will make it 3 5 with space, 3 5 6 7 8 9, and it will look like this. That we can form a matrix using this, and A prime will give the transpose of the matrix, that is, a row are becoming column and column are becoming row. Now we want to evaluate inverse of a matrix. Consider the matrix C equals to third bracket 1 2 0 2 minus 1 0 0 0 minus 1. The matrix looks like this. If we want to get inverse of the matrix, then it will be written as inverse of C. Then this is the inverse of the matrix. So inverse is obtained very easily using the Scilab code. We can get the eigenvalue of a matrix and the eigenfunction also. Consider a matrix like this, a simple matrix 1 1 1 1 1 1 1 1 1, and this will look like this. If we want to know the eigenvalue of the matrix, we write the command as spec of d equals to this. The eigenvalue is this. The values are quite absurd. Note this is a very small value, into -16 and then 17. To clear the value, that is to get clear, we write a matrix E equals to SPEC spec D. We are defining another matrix E and we clear the value and the wrong type for input argument and clean, sorry, and clean E. It looks like this. That is the small values are coming out 0. It is very small, so comes out 0. 0 0 3 are the eigen values. If we want to get the eigenfunction of the matrix, then we write the command as x comma y equals to x comma y equals to spec of what was the matrix? The matrix was D, spec D. Then it looks there is a problem. It is not dot, you have to make a comma. So go to that portion and we can up down key, use the up down key and get the previous command, and let us see. What we see that that these are the eigenfunctions, x1, x2 and x3 the eigenfunction, and the diagonal elements are in the diagonal matrix, and the eigenvalues are in the diagonal element, and we clean it, clean y, then this will look that 0 0 3. We can get the eigenvalues and eigenfunction of the matrix very easily using Scilab. So now we go to the we get the diagonal matrix. So if we get the diagonal matrix, in case of getting the power of a matrix, we have to find out the diagonal and then power. Here we can get the power of a matrix directly. This is a no, this here is a matrix name is, the matrix name is D, D, and it is in the small d. So the is not defined, so D, the D have 10, then it is comes out as this. So power of a matrix can be evaluated using this. So matrix operation can be done easily. We are cleaning the console and we are coming to the next item, that is the polynomial. How can we define a polynomial? Polynomial can define in two ways. P equals to poly, the command is poly bracket third bracket. You have to write like this: 1 space 2 space 3 4. These are the coefficient we are writing, and this comes out as and it will give the value this. So polynomial is, we see that the first element is this, second element is the power of z, here it is z, so the z, and third is z square, and 4 is z cube. Like this we can define a polynomial using the coefficient. We can define polynomial using also the root of the equation equals to a polynomial which has two roots like 2, 3, and the roots and it will z and it will look like this. So using the coefficient and also the root of the equation, we can define a polynomial function. And the root of the to verify the root, to have the roots of p, it comes out is like 2, 3 and 2, so it is all right. So we can also, using this, we can get roots of a nth root of unity. How can we write nth root of unity? Means the x cube or x3 or x4 or x to the power n equals to 1. Consider x cube equals to 1, then x cube minus 1 equals to 0, x cube minus 1 equals to 0. So x cube minus 1 can be written as, using coefficient, q equals to poly x cube minus 1 space x has no power, 0, x square has no power, 0, and x cube has power 1. So this and this can be written as z. We are just writing the polynomial, then we will solve. So it is a z cube minus 1. So root of this equation has the cube root of unity. So roots of q, these are the roots of cube root of unity. We can do it also using a program. We can write the program using this thing. This is this. We can we have we can get the roots of equation using a like this program. You can short program, that where we can write that clearing all, the n equals to 3, the cube root of unity. So the nth root equals to cos of 2k pi by n plus I sin. Using the complex variable, we can write that 1 equals to cos of 2k pi plus sin 2k pi, because 2k pi of sin is 0 and cos 2k pi equals to 1. So nth root equals to 2k pi by n and sin 2k pi by n. So the value can be 10. To run this program, we use this execute and save and execute this option, and we do this. What happens when we execute and this, we get, when to clear the console, no, we get the root of unity are this. So these are the same. We are using here just writing a line using polynomial, and here we are writing a small program. So we can do the roots of a equation here. To write a program, we can go to here and write the program file, and after writing program we have to file save option, save with proper location, and we can get the new code to run. Now important thing here, we go to the another important thing, that we sum of an infinite series, the minus 0.2 to the power n or 0.02 to the power n, 0.01 to the power n can be evaluated using Scilab computing, using the program like this, where we are running the program n equals to 5, that is we are taking 1 point, sum equals to 0 the initial value, for I equals to 1 to n, that is n equals to 1 2 3 4 5, p equals to, p is a number, we are giving the 0.02 to the power I, that is 0.02 to the power 1 plus 0.02 to the power 2, and all will be summed up and like this, and the sum. Using this program we can find out the sum of a infinite sum of a number like this. We can change the value like 7, and we get the value like same value because of the saturation, and giving the same value. And now we go to another thing, the differential equation. Differential equation can be solved, differential equation can be solved using Scilab programming. We consider the problem like this. For the first case, the first order differential equation with boundary condition. The equation is dy dx equals to 2 minus x with y equals to 0 and x equals to 0. We have to plot the function from x equals to 0 to x equals to 10. To plot the function, what we do is that we write the program like this, that is we have dy dx equals to f of x and y, right? Fx with y, we are writing dx, we are writing dx, the function fxy, and what is dx? Dx equals to e to the power minus e to the power, dx equals to e to the power minus x. So dx equals to e to the power minus x, and the function is ends, and these are the boundary value. Boundary value is x0 equals to 0 and y0 equals to 0, and for these values of x, or for these values of the variable t, we have to find out the differential equation given. The function is OD, the first two term is the boundary condition x0 and y0, in terms of for what values we want to get, and f is the this function f, and plot, we want to plot the function. For this we get what we get when we run this program. We get a graph like this, a graph like this. We can change the value like this to 2 star x, then what happens to the function? It looks like this, and what happens to, and it is 3x, then it will be moved down, and beautiful curve appears using the code. And similarly we can get the second order differential equation. The problem is like this, second order differential equation. We have to solve the second order differential equation with boundary condition d2y dt square plus 2 dy dt plus y equals to 0 with y2 at the point 2. At the point t equals to 2, the value of the function y and its derivative equals to 3 and minus 2. So we have to find out the y and y prime for different t, or the different values of the t, and we are plotting and y prime for different t to plot this value. So to have this, we have written the program like this. And we got that we had d2y dy square equals to minus 2 dy dx minus y. We can write this as the function as earlier, dx equals to t f of t comma x dx1. It is the derivative of x equals to x2. The dx2 means double derivative of x, dx2 double derivative of y, that is double derivative of y equals to minus of 2 star of x2. x2 means first derivative of x and minus x1. We write the differential equation like this, and the boundary condition t0 equals to 2. For that, first is the first differential equation, and second is the first y and is the y prime. And for these values of the function, we have to evaluate the ordinary differential equation x0, t0, tf, and we have to plot this. So when we run the this, we get a curve like this, and we have plotted we have going to get the y value. If we want to get the y prime value, then the graph will look like this. So these are the two curves. For first one was the for y, and second one is y2. So we beautifully get the curve plotting, and we can get also the for a particular value at a point using the display command. So using Scilab, we can easily do the programming. So this is the very preliminary discussion about the Scilab programming. Thank you.